at the table. It's got an f of x and a g of x, and it has the x values and then their results. Okay? So if you had, of course, we're going to substitute in what x value? -1. Okay? And if I go to -1 here, what's the f of x value when I plug in? Write that down. Okay? I'm literally just substituting in the -1. Okay? I don't have to crunch numbers. I'm not even given the function. I'm given table of values. Okay? Now, what is your f of -1 value? 5. Does everybody see that? Yeah? If you don't, you better say. -3 times, what is g of -1? -7. Folks, figure out what that, what's it equivalent to? 5 what? What's -3 times -7? Plus 21. 5 plus 21 is 26. If I give you a table like that, would you be able to cipher it? It's kind of like a map, bless you. Would you be able to do that on your own? I hope so. Look at example 2. Find the value of k for which the limit of g of x divided by f of x as x approaches k does not exist. Where does it not exist? Say it again.
Would any of them exist with zeros in the bottom? So like if it was f of 2, does it matter what's in the top?
So k needs to be what? K needs to be 2. Why? Now this is the piece, remember I told you, it's no more, in calculus, no more x equals 3, circle it and you're done. This is how you need to get accustomed to solving and answering your problems, especially for FRQs, okay? K approaches 2. You may want to write, when K approaches 2, f of x equals what value? 0. Then, the limit will not exist. But when k is approaching 2, folks, you will have, and this is just for your notes, and I don't want to, just for your notes, you may want to put in the margin, if k was 2, then it would be g of 2 over f of 2. Well, what's g of 2? -4. And what is f of 2? 0. And that's like bells and whistles should be going off in your head. Why? Because that value, 0 is under the fraction bar, so the value is undefined, right? Yeah. But this would be a really, really good answer. That right there should just be there for your notes, your own knowledge. This is the why. This is the what. Okay? Does that make sense? Be prepared. You will see another table, guaranteed. And you have to be able to interpret what you see. Questions at all? Any questions? Easy stuff so far? Yeah? All right, so let's roll on then. Squeeze theorem, I told you, there it is. Go on Khan Academy, and I want you to learn. Just watch that video. It's just a short video. But squeezing function g between functions f and h forces g to have the same limits, L, whatever that value is, at x equals c as do f and g. It's something that we used, and it just warrants me having to say, you know what, it's in your notes, we've gone over it. Okay? It's all right, folks. This is kind of simple. I don't even know that you really should put this in your notes. I hesitate to tell you not to put it there because it's kind of common sense. Look at these. You know whatever the number is, you plug that into x, right? So what would the limit of sine of x be as x approaches c? Sine of c. What would the limit of cosine of x be? Cosine of c. This is why I don't really know that you need to write these 6 properties down. Of course, it would be tangent of, cosecant of, secant of, cotangent of. What if x approached box? Then it would be sine of box, right? That, you see what I'm talking about? I don't really know that it warrants you writing those down. I would definitely make reference to theorem 2.6, which is your limits of the transcendental functions. Those are not the most important ones that we're getting ready to go over. There are 3 special properties that we will use, and they aren't even the ones that down here at the bottom. But definitely I'd reference that. And it's at minute 6 if you want to go back and watch that, okay? What about these other 2? These are your exponential. Transcendental functions include your trig functions and your exponential and your natural logs, those functions, okay? What would the limit of a to the x be?
A to the C.
A to the c. What would the limit of the natural log of x be? Natural log of c. Do you understand why I talk? If you put it in your notes, great. If you don't, that's okay. Just, we're still factor, simplify, evaluate. Do I have anything to factor in these? No. So now we're into simplify, right? So just look at the first one. Remember, you got to know your unit circle. So what am I going to do for the limit x times cosine x as x approaches pi? Plug in pi. For real, is that all I do?
Yes, ma'am.
Yeah, for real, that's all you do. What's the cosine of pi? Well, where's pi?
Pi is on the
It's
right.
over here. I saw a hand go over there. What's that ordered pair? Negative 1, 0. What's the cosine? Aha! Negative 1. So what is your answer? Shut your faces. Easy. Right on. Feel good, feel groovy?
Yes, ma'am.
Yeah? Do the next one. You don't need me to talk you through that. Go. Everybody have something on your paper? Yeah? How many of you had that right there? Did anybody have that? How is that not the right answer?
It is. Oh, God,
It is the right answer. That is an acceptable solution. What did I do?
You just times the 1 to the E.
What's the negative?
What's negative 1 times anything? Negative that thing, right?
You don't have negative.
Do what?
Yeah. Don't have negative.
I can have the opposite of E.
What do you do with
Oh.
exponents?
What do you do with exponents? You can't have that. That is an acceptable solution.
Oh.
Why is the E positive instead of being negative?
Yeah.
Because it's just a negative. It's the opposite of 2.7. What's the opposite of 2.7? Negative 2.7. You're right, it isn't. Because, Jacob, what did you ask?
Well, what is it? Because what I ended up doing was
Oh, shut
negative
up.
exponent.
My bad. I'm like, what am I doing? I'm sorry. That's my bad. My bad.
What does the exponent do?
What does the exponent do? Time out. My apologies. I really don't do these things to scare you or to like mess with you. I promise I didn't do that. I just made a sign mistake. I'm human. It's the first mistake I've made all day. Just kidding. What's gonna happen with it? Pardon me? Why? Because it's a negative exponent. We don't like you, negative exponents. We do not like you. I do not want a negative exponent. They are E. E. So we're gonna move that thing down. 1 is automatically under the E, right? So if I move that whole thing down, what's gonna be left in the top? I could leave it as -1. I could leave -1 up there. Because it is negative E, right? But when I'm gonna take that E and move it to the bottom, what happens to its exponent? It becomes a +1. Remember that? Now, remember also that a negative sign is like treated as a floating negative. It can either be at the top or at the bottom or smack dab in the middle. It just can't be where? It can't be, well, yeah, it could be an exponent. But can I have a negative in both places? No, what would happen? It'd be a positive, okay? This negative E to the negative first is acceptable. It's like 2/4. I don't like it, but I deal with it. This is better, that's like 1/2, okay? They are both the same value. I didn't mean to scare you on that one, sorry. Y'all were looking like, what are you doing? I got it. Questions?
If you do it like the exponent in the first, can you do the exponent in the first step?
Like, this? Oh, or nuggets. Like that. Just go from here to here.
Well, like we would have -1 times -1 over E.
Oh, yes.
But then you cancel, you can do -1 times, sorry, negative. Well, I'm asking because mine's positive.
This? No.
Okay.
Look, -1 over 1 is good, right? 1 over E is E to the -1, right?
Oh, okay.
What's a negative? You see, you did the same thing I did. What's negative times positive?
Okay.
-1 over E. Okay? Same tomato, I say. Got it? Any other questions? Is this okay? All except for me trying to scare you.
I have a
Confuse you.
question.
Yes, ma'am. 3
Uh,
properties, 3 limits, 3 special limits you have to know. You have to know them. Period. Got to. If you don't know them, you will not do well. Have to know them. It's pretty mean to say, isn't it? That's pretty hateful, Miss Perry. I'm just being real. If that comes off as hateful, so be it. Learn them. That's right. Keeping it real. Hey, let me be real with you. Play some chess, folks. Well, I'm not really good at it. However, I don't even know how to play it. Forget that. I'm not really good at it. I don't even know how to play it. I ain't really good at checkers either, but I do know how to think forward and think ahead. And folks, I told you this morning, we're getting ready to enter the land of chess. You've got to put yourself in a situation where we use the special limits. I want to see sine x over x. I want to be able to see 1 minus cosine x over x. We're really not going to see the E thing. Just ha, okay? But be prepared. If you do, you need to know it. We're going to use the sine and the cosine in a minute. Where would you think you would even start with this? I only have 2 special properties that are really, really important to this. Could I write the sine over cosine? Could I do this first? What do you have to have? Along with your big girl panties, you also have to have that what? You gotta have good elastic always. But don't you have to have that ninja belt? You got your algebra ninja belt on? How about, can I suggest this to you? Would I just do that? Old school. I kind of went old school. I unsmushed it, didn't I? Folks, you got to get real comfortable with smushing and unsmushing. Why did I do that?
So you get the 0 out from under it?
No, that's not why. So I can go sine over cosine. Why? Because that's what tangent is. It's a game of chess. Check this out. We only have two properties really that we're going to use a whole bunch. I can't cross multiply unless I see an equal sign.
Well, the X in the post.
Shut up. Say what?
Switch the X in the post.
So you're saying that if I write it this way, that's okay. Is that okay? Mathematically, is that legal?
Yes,
Why?
because you're multiplying across anyway.
Because I'm multiplying across anyway. Do y'all remember what property that is? The multiplication. The what? The commutative property of multiplication says I can change the order of numbers when I'm multiplying, and it's okay. What's 3 times 2? What's 6? What's 3? What's 2 times 3?
6.
Okay, we change the order, we still get 6, right? So, why did I do that?
So that you can do your special limit properties.
Do I have it set up now where I can use the special limit of, which
Yes,
one?
ma'am.
Sin x over x? What do you think I'm going to do? Hold on. What will allow me to change this to 1? What am I really doing? I'm finding the limit of each of these. Just for your notes, I want you to write this. I know on your homework, I know on your quizzes, you are not going to write this. Heck, I don't need my notes. But you need to know why this right here is going to turn into what? Why? Because it's a special property. That's one of our properties we can use. What are you going to do to that 1 over cosine? Plug 0 in. 1 over cosine of 0. Well, heck, now I got to do trig. What the crap? Where's 0? Abby's like right there. What's that order pair?
1,
The order pair is 1, 0. What's cosine?
1.
1. Are you with me? Yes or no? Yeah.
Another one.
Yes? No? Everybody with me? So we got 1 times 1 over 1,
Which is one.
which is plain old 1. Are you kidding me? All that work for 1? Can you do that on your own? Yes, you can. Yes, you can. And you better. And you better not count chat at all. And then on a quiz, you can't do diddly squat. No. You'll stack your bones there, sweet honey. What if, oh God. Oh my God, look at the second one. Welcome, calculus.
That's fun.
That's not.
Well, what, Katie?
That's a good one.
Well, it does look like it's.
Oh, it looks like both. How can I make it into 2 things? Sin x over x times 1 minus cosine x over what, Joy? X. Is that true?
Kessler's outside.
Is that true? Is that okay? Is that legal?
Yes.
Don't do things that aren't legal
We'll cover it.
in math and in life. What is the limit? Is x approaching 0 sin x over x? Say who?
1 times.
Oh. 1 times what?
0.
Which is?
0.
For real, all of that and we get a stinking 0. Yep, all of that and we get a stinking 0. Question? Yes. Just a yes, I got the answer. Is that so bad? Do you understand why I kept telling you had to be an algebra ninja? You have to be very comfortable using the commutative property of multiplication. Very comfortable. Smushing and unsmushing. How about this next one? Check this one out. Oh. Oh. Pardon me? Does it look kind of like one of the properties? How would it look exactly like one of the properties? Get that 5 away. Kick it to the curb. How can I kick it to the curb? What? 1 over 5 times what, DB?
Sin x over.
Shut your face. Is that okay? Total, you see what I'm doing? Does that make sense? Yeah? What now?
Times 1.
1/5 times who?
Lane.
Shut up. Y'all think I'm so smart. Is that the answer? Yeah, it is. Is it so bad? It's not so bad. Just strap on that Alfred Ninja belt. If your pants pulled up high, you got this, right? Now this one's kind of weird. We need to put this is 2-star work. That means it's kind of crazy. Okay? Does it look kind of like something we could use? How? Uh-oh. Go back to your properties page. I'm going to put you a little helpful hint in here. This one right here. Okay? Somewhere around this, right here. I want you to write this. The sine of 2x over 2x. Do your functions match? 2x match 2x. What do you think the limit would be? It would be 1. Do your functions here in the original property match x and x? And it's equivalent to? If I had the limit of x approaching 0 of sine of x squared plus 2x over x squared plus 2x, what would it be equivalent to? Do you see how the functions are the same? Okay, now go back to the example. Right, have it. What do I have to do? What do I need to remove? Can I touch the 3? I can't touch 3 because it's smushed in between sine and x. I can't touch it at all. I could move the 2 out. How? 1/2. All right, let's rewrite. 1/2 times sine of 3x over x, right? Think ahead, playing chess. What do I need to be able to use that special property? The same function. No, I can't touch that 3. It's kind of protected. But if I had a 1 on the bottom, it would be okay. If I had a 3 on the bottom, it would be okay. How can I legally put a 3 on the bottom? Shut. Why? Because it's a convenient form of 1. If I no, not combine. If I multiply the whole thing by 3 over 3, why is that okay? Because we're really just multiplying by what?
1.
We're only multiplying by 1, so is it going to change its value? No. We're just changing its outfit. Now, will you tell me what I'm going to do? Smush what?
3. Bottom 3.
The bottom 3. Where am I going to put the bottom 3?
On the x.
All right, so I'm going to have 1/2 times 3 over 1 times sine 3x over
3x.
3x. Is that okay?
Yes, ma'am. Yes, we need 1.
And what's going to equal 1, Sam? Sine of 3x over 3x is when I take the limit of it, it's 1 times what?
3.
Over?
Good.
1 times 3 is 3, 2 times 1 is 2. What's 3/2 times 1? Now, what am I going to do? Because I want to get you on this right now. And it's time. Yep.
For that, couldn't you just, whatever you had in your sign and whatever you had in the denominator, you just put those in a fraction?
Hold that thought till tomorrow. Hold that thought till tomorrow. We got to prove everything.
Sound about-
Hold that thought. You know where this is headed. You know where this is headed. All right. For today, this is how we get to that answer. Okay? I know what you're looking at. I know what you're looking at. Here's what you're going to do. Okay? If you want to go I'm gonna put this on Instagram, so you're free to leave. If you wanna wait for me to figure this out, you may sit here and wait, but you don't have to. And I'm not gonna be mad if you leave, so you may. Page 87. Y'all have a good day.
That's it, right?
No.
I watched the video last, but I can't remember how to get to them now. How do you get to the video?
There you go, y'all. Thank